So, chapter 3 is a chapter on functions. Functions were a topic that apparently I didn't really understand. I actually took my Calc 1, Calc 2, and Calc 3 at Glendale Community College over 30 years ago, got A's in them, but apparently I really didn't understand function notation all that well because when I got into grad school, um, and I kind of had to learn on my own. I just couldn't really read the higher mathematics because it was everything's in function notation, and I didn't learn it good enough. So we're seeing it a lot of material a second time in this chapter. I lifted a bunch of the material that we're going to do in this chapter from my Math 114 class. So some of you that had me before, so about half of this chapter is going to be repeat, and the other half's going to be new material. Um, I lifted some stuff from my Math 114 class, and I just put it on the screen right now. It's just some words and definitions. I never test on definitions, but as I use the words when I lecture, it'd be nice if you knew, what the words meant. So I have a few definitions. A relation is any set of ordered pairs in the forms x comma y. So here would be an example of a relation. Usually, if I would give a relation a name, I would give it a capital letter name. So I'll make my relation R equals, and then I'm just going to make a set of ordered pairs. Maybe the point 1 comma negative 3, 2 comma 6, and a comma 9. The points in the ordered pairs don't have to be numbers, but they usually are. This is a relation that's made of 3 ordered pairs. And usually when we write relations, we capture the points in these squiggly set braces the best we can. So this is an example of a relation with just 3 points. It would be considered a finite relation. There are relations that have infinitely many points, and it would be impossible to list all the points. The domain of a relation is all the x values in the ordered pairs. So for this particular relation that I just created, kind of without really doing much thinking, the domain of this relation would be the numbers 1, 2, and the letter a. Because this is a finite relation, when I write the domain of a relation, I also usually capture the elements in a little squiggly set braces. So if I have a finite relation, I can list all the ordered pairs. If I have an infinite relation, I couldn't list all the ordered pairs, but I could still describe the relation, and we'll get to that in the next section. Next bit of this is the range of my relation. The range of a relation is all the y values in the ordered pairs that make up the relation. And my y's are negative 3, 6, and 9. So the range of this relation would have the numbers negative 3, 6, and 9. And similarly, when there's a finite relation, meaning there's only a countable number of points that make up the relation, I usually put the elements of the range in set braces as well. In the next section, or maybe 2 sections up, we'll get to infinite relations, and how we describe the domains and ranges will be different. But when a relation is just a finite number of points, it's pretty easy to describe the domain and the range. So some relations are functions, and some relations are not functions. This is a big deal in this chapter. It comes up a bunch of times. And so I'm going to write an example of a relation that is a function and a relation that is not a function. And I'm being lazy here because I'll be lazy throughout the chapter, but I'll write something not so lazy here in a second. So to give me this relation, let me call this relation A. This relation I'm going to have 4 points. The point 1, 2, 3, 4, 5, 6, and 4, 2. I claim that this relation is a function, and I'll tell you why it is a function in a second. And I'm going to make up a relation that's not a function. I don't know that I can get 4 points here. Maybe I'll just do 3 points. How about 1, 2, 1, 3, and 2, 7. What makes a relation a function or not a function has everything to do with the x's, nothing to do with the y's. The second relation I say is not a function, specifically because there's duplicate x's. There's two x's with different y's. So if there's 2 or more points with the same x, we say the relation is not a function. In this world, each point, and for my relation A, I only look at the x's to determine whether the relation is a function. And because all the x's are different, this relation is a function. So this is what I normally say. This relation is a function. This relation is not a function. It is probably more proper to say, because this function, the domain is x's and the ranges are y's, it's probably more proper to say in this particular relation, A, that is a function, we would probably properly say y is a function of x. This is the proper verbiage when a relation is a function and the domain is consists of x coordinates and the range consists of y coordinates. Similarly, for this relation B that wasn't a function, because the domains are x's and the ranges are y's, it's probably more proper to say y is not a function of x. But I'll use these interchangeably. I'll say the relation is not a function, or y is not a function of x, and those will have the same meaning to me, meaning that if I listed all the points in the relation, there'll be 2 or more points with the same x. And then I'll use interchangeably a relation is a function or y is a function of x. I'll use those phrases interchangeably, and both of those will mean that all the x's are different in the relation. All right, that should be enough theory to get through a lot of this chapter. There might be a little more theory that we'll get through this section. There's going to be a little more theory as we get deeper into this, but I don't want to do all the theory right off the bat. So problems 1 through 4 give me diagrams that I'm sure I lifted from Google. I have no idea how to create these diagrams. And these are diagrams of finite relations, meaning it's possible to list all the points. In each of the problems on the screen right now, I'm supposed to list the points that are implied by the relation for part A. So in problem 2, if I was doing part A of number 2, I want to list the points that are implied, and the arrows tell me the points, they help me create the points. The left circle or the left oval is labeled X, the right oval is labeled Y, and there's lines going from an X to a Y, and I'm just going to create points by those. The first point I'm going to create is 1A, because that's the line going from the X to the Y, and then 2D, and then 3B and 3C. This is the relation. I didn't take the time to name my relation. I don't have to name my relation, but I should capture it in these squiggly set braces. That's the points implied by the relation. Part B wants me to list the domain and the range of this relation. The domain is going to be the x's, the range is going to be the y. And I could look at the points that I created, or I could just look at the diagram. The domain is just going to be the numbers 1, 2, and 3. And the range is going to be the letters A, B, C, and D. When there's a finite relation, meaning that you can count the number of points that are in the relation, it doesn't really matter when you write the domain and the range, the order that you write the numbers or letters or items, objects in, but I usually will write numbers in increasing order and letters alphabetically. But had I written for my domain for number 2, if I wrote 2, 3, 1 for my domain, because it's a finite number of points, the order isn't important. When we get a little bit later into the chapter and do infinite relations, the order is going to be a big deal. So that's part B. And part C is determine whether y is a function of x. I look to my points. I have 2 points with the same x's. I'm going to say y is not a function of x, or this relation is not a function. It's the proper way to say it is saying y is not a function of x. The more common way to say it, I would just say this relation is not a function. They're equivalently correct answers. This is the more mathematically elegant way to say it. The lazy way to say it is the relation is not a function. Would it be fine? So problem 4, boy, the graph is getting hard for me to look at, but let me try to do 4a. Create the points implied by the relation. There's a line from -1 to +2. So the point -1, +2 is going to be in my relation. There's a line from 0 to +2, so the point 0, 2 is going to be in my relation. There's a line from +1 to -3. From 2 to -2, and from 8 to 3. So that's the relation. Because there's only a finite number of points, these set braces that I can't really draw are the appropriate symbols to capture the points in. For 4b, it wants the domain and the range. I can look at the points, or I can look at the pictures. It's almost easier for me to look at the pictures. The domain is going to be the numbers -1, 0, 1, 2, and 8, which I could see easier in the bubble than I can from the table or from the points that I created. And again, it's proper to put the domain in the squiggly braces, and the range is going to be -3, -2, +2, and +3. Done with 4b, on to 4c. Is y a function of x? The answer is going to be yes, because if I look at the x's, there's only 1 point with an x of -1, there's only 1 point with an x of 0, there's only 1 point with an x of +1, only 1 point with an x of +2, there's only 1 point with an x of 8. There's no 2 or more points that have the same x. So I could say is a function. How about, this would be the lazy way to say it, the relation is a function. The non-lazy way to say it would be y is a function of x. I'll use those interchangeably because every relation that we do, the domain is made of x's and the range is made of y's. The next problems are basically the same problem, except instead of having the bubbles, I actually wrote points. And but I only gave a part A and a part B. I didn't say to list the points that make up the relation because they're painfully obvious. These are finite relations. My problem 6, the relation has 4 points in it. And for 6a, I'm supposed to list the domain and range of my relation. And then B, determine if it's a function or not. So for 6a, if I want to write the domain, I'm just going to pull off the x coordinate of each point. First x coordinate moving from left to right is -5, then +2, then +4, then +7. So the domain for that would be the -5, 2, 4, and 7. The range, usually I go from bottom to top. The lowest y coordinate is 1. The second lowest y coordinate is 3. The third lowest y coordinate is 4. The fourth lowest y coordinate is 6. That would be the range. And for part B, I look at the points and there's not 2 or more points with the same x, so this is going to be y is a function of x. And if you want to be lazy, you can just say the relation is a function. If you have, when you're going to find write the domain or the range, if you have duplicate x's or duplicate y's, you only have to write the number once. So in problem 8a, when I go to write my domain, I'm going to write the x's, and if an x occurs in more than one point, I'm only going to write that number once. So the first furthest left points both have x's of -5. I'm only going to write one -5 in my domain. And then there's a point with an x of 0, a point with an x of 1, and a point with an x of 3. I'm going to write that for my domain. Similarly, if 2 or more points have the same y, I don't need to write that y value twice. I'm going to go from, usually when I'm listing my domain, I read from left to right. When I'm doing my range, I list from bottom to top. So the bottommost point has a y of -3, and then the second lowest points both have y's of 2. I'm only going to write that 2 once, and then I have a point with a y of 4 and a point with a y of 6. That's done with part A. Moving on to part B, is y a function of x? The answer is y is not a function of x because I have 2 or more points. Actually, I have 2 points with the same y. So this is not a function. The proper way to say it is y is not a function of x. So this section isn't particularly hard, but you notice I'm not doing a heck of a lot of algebra, which means it's really hard for me to give partial credit if you make mistakes. And some of these problems have a bunch of parts, and when problems have a bunch of parts, oh boy, if they're 2 points each, all of a sudden a simple problem could be worth 12 points. And if you don't understand the concepts and it's a problem where you can't get partial credit, bad things happen. So problems 9 and 10 have functions. They're relations where they don't have duplicate x's. They're listed as a set of points. The first 2 questions are easy. They ask me to find the domain and the range. So for problem 10a, to find the domain of the function that I've written, I'm going to make my squiggly braces and list the x's in maybe some nice order, but it doesn't matter if I don't write them in a nice order. If I just went, the domain is 1, 2, -4, 5, -3, 6, makes no difference whatsoever. But I'm going to take the time to write these from smallest to biggest. The smallest x value is -4. Second smallest is -3, and then 1, 2, 5, and 6. This would be the nicest way to write the domain, but hardly a deal if your numbers were scrambled. When the function is only a countable number of points, the order that you write the domain numbers in, or the range elements, don't matter. I'm going to do the same for the range, smallest to biggest, and pick out the y's. -3 is the smallest y. -2 is the second smallest y. +2, +5, and +7 are the rest of my y's. I know I'm going to make mistakes in these videos. You know, if the mistake, just because it's, I don't know, for some reason I'm just not that accurate. Even when I write my tests, I don't get 100% on my keys. So if my mistake is if you see it and it's really bugging you, let me know. If you can just tell, if you could understand what I did wrong, that's the best thing in the world. When I make a mistake and you see that it's a mistake, this is a good thing. The next 4 questions ask me to function questions, and each question calls out one or more of the points. Question C, when I see a number in a parentheses next to the name of a function, this doesn't mean to multiply by 2. The number inside the parentheses represents an x. This right here, question C, what it's asking me to do is to find the x coordinate, to find the y coordinate of any point that has an x equal to 2. So problem C, it's calling out the point 2, -3. The point that I'm searching for, the point that's referred to in question part C is the point 2, -3, specifically because in function notation of what this is, a number in a parentheses represents an x. So my answer to part C, I could just write the y coordinate because that's all it's wanting, or I could write the problem followed by the y coordinate, which is kind of the better way to do it. But this is asking for -3 as an answer. D is written the same way, so it's asking me to find the y coordinate of any point that has x equal to 5. So C called out that point 2, -3. D is calling out the point 5, -2, because that's the point that has an x equal to 5. And a best answer to part D would be to say f of 5 equals to -2. The next style of questions, E and F, ask me to find x coordinates given a value of y. In function notations, numbers in parentheses represent x's, number to the right of equal sign represent y's. So what E is asking me to do, it's asking me to find the x coordinates of any point, possibly points. So I'll parenthetically an S after this, that have, I guess, a y equal to -3. So question E is calling out the first point and the second point. The points E are calling out are the points 1, -3 and 2, -3, because both of those points have y is equal to -3. When I go to write my answer for question E, I'm going to probably write x equals, because those are x's, that I'm going to write next to the x. So x equals 1 and 2. Question F wants me to find all values of x, so it's hinting that I need to find an x that have f of x or y equal to 2. Anytime I see a function symbol, in my mind, I can change that function symbol to the letter y. So find all values of x such that f of x equals to 2 has the same meaning as find all values of x such that y equals to 2. And the only point that I can see right now is the point -4, 2. I don't see multiple points that have y's of 2, but it's going to happen in this video that I missed something and I write down the wrong answer because I'm just not seeing something that I need to see. So that would be the answer to part F. More questions that are exactly the same, just more practice doing this. And so we go through these a little bit quicker. 12 gives me a function, I named it g. Lowercase letters are usually what we name functions with. And nothing. Let me just write the answer. And let me get lazy here just to save some time and make it so I don't make a mistake. You don't have to write the domain in ascending order, and it's actually harder to do that. And so because I don't want to make a mistake, I'm just going to list my domain by taking the x's in the order that they came. rather than taking the time to write them in a nice order. When I make mistakes is when I try to write a nice answer, the nicest possible answer. And the nicest possible answer would have the numbers going in ascending order. But it's not wrong when it's a finite function to just take the numbers in the order that they're written. The y's can duplicate, and usually when I'm writing a range, I never duplicate a y if it's duplicated in the points. So I wrote this y, -3, that y 2. I'm not going to write that -3 again. I'm not going to write that 2 again as I go to write the range, and then I'll finish up writing this 1. Done with my A and B. C and D, the numbers that are given are x's. The point that C calls out is the point 1, 2, because that's the point that has an x equal to 1. The best answer for part C would be g of 1 equals to 2. If you just wrote 2 on an answer blank, I can live with it. D is calling out the point -3, 2, because again, in function notation, if you're given a number inside a parentheses, that number represents an x, and the point -3, 2 matches what I'm given in part D, that the x is -3. The best answer for part D would be g of -3 equals to 2. Part E and F give me numbers to the right of an equal sign, which are y values in function notation. I can really think of question E as saying find all values of x such that y equals -3. Function notation and x and y and the variable y are interchangeable. Question E is calling out the point 5, -3 and 2, -3 because those are the 2 points that have y is equal to -3. So my answer for question E is just going to be x equal to 5 and 2. Probably would be nice to write the numbers in ascending order, but it doesn't matter. Question F is calling out just the point 6, 1. Again, asks me to find all values of x such that g of x equals to 1, or all values of x such that y equal to 1, and there's only one point that has a y equal to 1. When I write my answer, I'm going to write the x coordinate of that point. A few more problems that are exactly the same. In fact, that's the whole rest of the video is all the same problems, which means I'm going to make this video spill over 30 minutes because I don't want to break it here. Let's look at 14. I'm going to find the domain of this relation by listing the x's. The x's are -2, +1, +3, +4, and +7. The range are the y's, which are -3, +1, double +3 that I'm only going to write once, and +7. I called this graph F. Part C wants me to find f of 1, so I look for points that have an x coordinate of 1. The only point that has an x coordinate of 1 is the point 1, -3. So for an answer to part C, I should write f of 1 equals -3. Part D, I'm looking for a point that has an x coordinate of 3, and that's the point 3, 7. In function notations, numbers in parentheses represent x's. Numbers to the right of equal signs represent y's. Best answer for part D would be f of 3 equals to 7. In part E, find all values of x such that f of x equals to 3. It's calling out the points that have y equal to 3, and that would be the point -2, 3 and +4, 3. For an answer for this kind of question, I'm just going to write x equals and take the x coordinates of the points that have the values that I'm looking for. And lastly, for part F, I'm looking for points that have a y equal to 1. And my answer is going to be the x. Maybe I'll just do one more problem, even though there's a few more problems, because they're not, once you get one, you get them all. So try to do 13. I'll flash 15 and 16 on the screen, but not do them. You can do, it's exactly the same style of questions. And I'll do one more problem, and then we'll move into section 3.2. So here, I've connected the points. Notice I don't ask you to find the domain and range, because when the points are connected, you can't just list the x's and list the y's to find the domain. You can't list the x's to find the domain. You can't list the y's to find the range, because there's infinitely many points when the points are connected. But I still can answer the function notation. This is a picture of a function that I call g. First one wants me to find g of 0, which means I need to find the point that has an x coordinate of 0. That's the point 0, -4. For part A of number 18, my answer is going to be g of 0 equals to -4. For part B, asks me to find g of -4, which means I need to find the point that has an x of -4, which is the point -4, +4. When I go to answer part B, g of -4 is going to be +4. C wants me to find all values of x such that y equals -4. This is calling out the point 0, -4, because that's the point that has y equal to -4. And my answer for this is going to be the x equal to 0. And D is all values of x such that y equals to 0. It's calling out the point -2, 0 and +2, 0, because those are the points that have y equal to 0. For my answer, it's going to be x equal to -2 and +2. And the slick way to write when you have the same number, one positive and one negative, would be to use a plus or minus sign. I'm going to flash up your last problem on the screen so you can do it without having to maybe open up the problems, but I'm not going to do problem 20. It's just kind of repetitive. So that's the end of section 3.1. Hopefully that was a good start to the chapter. It's important. This skill is worth a lot of points on the test, and it comes up, I think, in other chapters.